Hi, my name's Nick, I'm a maths tutor, and today we're going to go through paper 1H from June 2019. Let's give it a go. There are only blue cubes, red cubes and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The number of red cubes in the box is the same as the number of yellow cubes in the box. Complete the table. So the probability of picking blue, red or yellow in total is going to be 1. So we do 1 minus 0.2, which gives us 0.8, and we're told that the number of red cubes is the same as the number of yellow cubes, so we just divide 0.8 by 2 and we get 0.4 for both. Then we are told there are 12 blue cubes in the box. Work out the total number of cubes in the box. So we know the probabilities for blue, red and yellow. If we multiply all of these by 10, we have 2 to 4 to 4. We know that there's 12 blue cubes in the box, so we can multiply this ratio by 6, and we end up with 12 blue cubes, 24 red cubes and 24 yellow cubes. We then add all of these together and we end up with 60, so 60 is our final answer. Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, 2 times as much butter as sugar. Dion is going to make 60 biscuits. Work out the amount of flour she needs. 50 grams of sugar gets us 15 biscuits. We need 60 biscuits, so we need to multiply both sides by 4 and we end up with 200 grams of sugar. We know that we need 3 times as much flour as sugar, so we do 200 times 3, which gives us 600 grams. Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. How many packs of butter does Dion need to buy? So 200 grams of sugar makes 60 biscuits, and we know this from the first part of the question. And we need double the amount of butter as we have sugar. So therefore 200 times 2 gives us 400 grams of butter. We need enough packs to have 400 grams of butter. So we do 250 times 2, which is 500 grams. So therefore 2 packs of butter is the answer. Find the highest common factor of 72 and 90. So we have 72 and we can write out a factor tree. So we have 2 and 36, and then that splits into 6 times 6, and then 6 can be divided into 3 and 2. Then we have 90, so we do 10 and 9 are factors of 90, and then 10 divides into 5 and 2, while 9 divides into 3 and 3. We can write all of these down, so we have 72 equals 2 times 2 times 2 times 3 times 3, which is the same as 2 cubed times 3 squared. 90 is 5 times 2 times 3 times 3, which is the same as 5 times 2 times 3 squared. The highest common factor is the highest number that we can get from both of these two numbers. In this case, 2 times 3 times 3 occurs in both 72 and 90, so that is going to be our highest common factor, which means 18 is our answer. The diagram shows the plan, front elevation and side elevation of a solid shape drawn on a centimetre grid. In the space below, draw a sketch of the solid shape, give the dimensions of the solid on your sketch. So a plan view is looking from top down, and we have a circle, and from the front elevation, looking at it front, and on the side elevation, looking at it from the side, we have a rectangle. In this case, that's going to be a cylinder, and we can use our grid to calculate the dimensions. So we know it's going to have a diameter of 4 centimetres, or a radius of 2, and a height of 5 centimetres. So when we draw our shape, we need to draw a cylinder, and we need to say that the radius is 2 centimetres or the diameter is 4 centimetres, and that the height is 5 centimetres, and all of that combined will give you 2 marks. Shape A can be transformed to shape B by reflection in the x-axis, followed by a translation CD. Find the value of C and the value of D. So the first thing we'll do is reflect in the x-axis as we're told in the question. This gives us our shape, and then we can think about the translation that's taking place. As we can see, we need to move 6 to the left and 1 down, which means we're moving minus 6 and minus 1. So therefore we get C is minus 6 and D is minus 1. A shop sells packs of black pens, packs of red pens and packs of green pens. There are 2 pens in each pack of black pens, 5 pens in each pack of red pens, and 6 pens in each pack of green pens. On Monday, the number of packs of black pens sold to the number of packs of red pens sold to the number of packs of green pens sold is 7 to 3 to 4. A total of 212 pens were sold. Work out the number of green pens sold. So we use this ratio of 7 to 3 to 4, and we find out the individual number of pens that are going to be sold. So 7 times 2 to 3 times 5 to 4 times 6 is going to give us the number of each group of pens sold. This gives us 14 to 15 to 24. In order to end up with 212 pens, we can take the sum of 14, 15 and 24, which is 53, and divide 212 by 53 to figure out what we need to multiply by to get the ratio of all of the pens. This is 4, so we multiply 24 by 4 to get the number of green pens sold as asked in the question. So 24 times 4 gives us 80 plus 16, which is 96, and that is the number of green pens sold, which is our answer. Here are 2 rectangles. QR equals 10 centimetres, BC equals PQ. The perimeter of ABCD is 26 centimetres. The area of PQRS is 45 centimetres squared. Find the length of AB. So because we know the area of PQRS, we can divide 45 by 10, which is the length of QR, to get us the width of the rectangle, which is going to be 4.5. Now that we have 4.5, we know that this is going to be the length SR and PQ, which is also the same as BC and AD because we're told that in the question. Using 4.5, we can figure out the perimeter of ABCD using the perimeter we're given in the question and in terms of x. So 4.5 plus x plus 4.5 is going to be our perimeter for ABCD. This is the same as 9 plus 2x, which is equal to 26, because we're told 26 centimetres is the perimeter in the question. So 2x equals 17, therefore x equals 17 over 2, which is the same as 8.5, which is our final answer. Work out an estimate for the value of the square root of 63.5 times 101.7. So 63.5 is approximately equal to 64, and 101.7 is approximately equal to 102. When we do 64 times 102, we can see that this breaks down to the square root of 64 times the square root of 102. The square root of 64 is 8, and we're left with the square root of 102. Now, because this is a bit of a nasty number to find the square root of, I can say it's roughly equal to 100, because after all, we're trying to find an estimate here, not the exact answer. So we do 8 times the square root of 100, which is the same as 8 times 10, which gives us 80. Moving on, we have 2.3 to the power of 6 is equal to 148 correct to 3 significant figures. Find the value of 0.23 to the power of 6 correct to 3 significant figures. So 2.3 divided by 10 is the same as 0.23. Therefore, 2.3 over 10 to the power of 6 is the same as 148 over 10 to the power of 6, okay? Because we're told 2.3 to the power of 6 is 148, and then 10 is on our denominator, and that is now to the power of 6. Therefore, we end up with 148 times 10 to the power of minus 6, because we've now flipped it up onto the top, and then we're left with 1.48 times 10 to the minus 4. Find the value of 5 to the power of minus 2. This is the same as 1 over 5 squared, which is equal to 1 over 25, and when we multiply this out, we can see it's 4 over 100, which is the same as 0.04. Work out 3.5 times 1 3/5. Give your answer as a mixed number in its simplest form. So first and foremost, we're going to convert to improper fractions. So 3.5 is the same as 7 halves, and 1 3/5 is the same as 8/5. When we multiply 7 halves by 8/5, we end up with 56 over 10, which is the same as 28 over 5, which is the same as 5 3/5, which is our final answer. The graphs of the equation 3y plus 2x equals a half and 2y minus 3x equals minus 113 over 12 have been drawn on the grid below. Using the graphs, find estimates of the solutions of the simultaneous equations. So, because we're given the same simultaneous equations as we have graphs on the grid, we can just find the intersection of both, and this will be our estimate for the solution. So, we read off our graph, and we end up with 2.25 and minus 1.3, and therefore x is 2.25 and y is minus 1.3. A bus company recorded the ages and years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. Complete the table below to show information about the ages of the people on coach A. So to find the median, we can see that we just cross off from either side and we end up with 59 as our median. To find the lower quartile, we just do the same thing on the left-hand side of 59, our median, and we end up with 53 as the lower quartile. And then we find the upper quartile doing the same thing, and we end up with 66. Here is some information about the ages of the people on coach B. Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? You must give a reason for your answer. So I said yes, the people on coach A have a median age of 59, while coach B has a median of 70, meaning the people on coach A are younger. Richard says that the people on coach A vary more in age than the people on coach B. Is Richard correct? You must give a reason for your answer. I said no, because the interquartile range of coach A is 13, while coach B's interquartile range is 19, meaning the people on coach B vary more in age than the people on coach B. Here are 3 spheres. The volume of sphere Q is 50% more than the volume of sphere P. The volume of sphere R is 50% more than the volume of sphere Q. Find the volume of sphere P as a fraction of the volume of sphere R. So we've drawn out from P to Q and Q to R, as we can see, and we know that 1.5 is the same as 3 halves. 3 halves times 3 halves is 9 quarters, which leaves us with 2.25 as our scale factor to get from P to R. If we want to go from R to P though, we need to do the opposite, which is 4/9, okay? So now that we know 4/9 is our scale factor, that is our answer. Given that n can be any integer such that n is greater than 1, prove that n squared minus n is never an odd number. So let's say n is 2k plus 1, where k is greater than 0. This represents any odd number, because 1 greater than any even number is always going to be an odd number. So now we swap in 2k plus 1 for n, and we get 2k plus 1 squared minus 2k plus 1. We expand this and we end up with 4k squared plus 2k plus 2k plus 1 minus 2k minus 1. This simplifies to 4k squared plus 2k, and as we can factorise a 2 from that equation, we can see that it is in fact even. Then we need to let n equal 2l, where l is greater than or equal to 1. In this case, 2l will always be an even number, because any even number can be divided by 2. So we replace n with 2l, and we get 2l squared minus 2l, which expands to 4l squared minus 2l, and as we can see, we can factorise a 2 from that as well, which means they are both even, and therefore n squared minus n is never an odd number, because every time we use an odd or an even number, we end up with an even number as a solution. Find the exact value of tan 30 degrees times sine 60 degrees, give your answer in its simplest form. So as you can see, I wrote out the table you see here for all of the values, and therefore tan 30, using our identity of sine over cos, gives us sine 30 over cos 30, and this simplifies to 1 over root 3. Sine 60 is the same as root 3 over 2, so when we multiply these together, we get 1/2 as our final answer. The diagram shows a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 10 centimeters, the base of the cone has a diameter of 6 centimeters, the hemisphere has a diameter of 6 centimeters, and the total volume of the shape is k pi centimeters cubed, where k is an integer. Work out the value of k. So first and foremost, we're told the diameter is 6 centimeters, so therefore the radius is going to be a half of that, which is 3. The volume of a hemisphere is going to be 2/3 pi times 3 cubed, because it's half of the volume of a sphere. So we have 2/3 instead of 4/3. This is 2 pi times 3 squared, which is 2 pi times 9, which is 18 pi. The volume of the cone is what we're given in the equation, so that's a third pi r squared times h, and replacing our values for r and h, we get third pi times 3 squared times 10, which simplifies to 30 pi. We add these together and we get 48 pi, so 48 is our value for k, which is our final answer. There are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4 or 5. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. Work out the number of different 3-digit numbers that can be set for the combination lock. So we just do 5 times 5 times 5, which is 125, and that is our answer. How many of the possible 3-digit numbers have 3 different digits? So we could have 3 digits where they're all the same. There's 5 different ways we could do this. We have 111, 222, 333, 444, and 555. We could also have a situation where we have 2 of the same digit. So there's 3 different options we have laid out here. Remember, 1 can be replaced with 4 different numbers, and then we can also replace 1 with 5 other options, okay? So therefore we have 3 times 4 times 5 as the number of ways we could have 2 digits in the same combination. So therefore that is 60, and we have 60 plus 5 as all of the options that we can't have in this situation. So we do 125 minus 65, which leaves us with 60, which is our final answer. Given that x squared to 3x plus 5 is 1 to 2, find the possible values of x. So because the ratio of x squared to 3x plus 5 is 1 to 2, we need to double x squared. This gives us 2x squared is equal to 3x plus 5. When we rearrange the equation, we get 2x squared minus 3x minus 5 equals 0, and now we can find the roots of the equation. We factorise this to 2x minus 5 times x plus 1 equals 0, and therefore our roots are going to be 5 halves or minus 1, so therefore that is our final answer. Express root 3 plus root 12 in the form a root 3, where a is an integer. So we can swap root 12 with root 3 times root 4. This then gives us root 3 times 2, because the square root of 4 is 2, and when we expand that, we get root 3 plus 2 root 3. Therefore, we have 3 lots of root 3, and that is our final answer. Express 1 over root 3 to the power of 7 in the form root b over c, where b and c are integers. So 1 over root 3 to the power of 7 is the same as 1 to the power of 7 over the square root of 3 to the power of 7. This is the same as 1 over root 3 to the power of 6 times root 3. Square root of 3 to the power of 6 is the same as 3 cubed, so we have 1 over 3 cubed times root 3, and therefore we have 1 over 27 times root 3, because 3 cubed is 27. To get rid of the root 3 on the denominator, we multiply by root 3 over root 3, which gives us root 3 over 27 times 3, which is the same as root 3 over 81, and that is our final answer. Given that x squared minus 6x plus 1 is equal to x minus a squared minus b for all values of x, find the value of a and the value of b. So we have x minus 3 squared minus b, because we're completing the square, and this gives us x squared minus 6x plus 9 minus b. Remember, this is equal to x squared minus 6x plus 1, because we're told that in the question, so therefore 9 minus b is equal to 1. This means that 8 is b, so therefore a is 3 and b is 8. Hence, write down the coordinates of the turning point of the graph of y equals x squared minus 6x plus 1. So because we've completed the square, when x is 3, that is going to be the turning point. So now we need to find the value of y when x is 3, and that is minus 8, so we end up with 3 minus 8 is our answer. H is inversely proportional to p. P is directly proportional to root t. given that h is 10 and t is 144 when p is 6, find a formula for h in terms of t. So h is equal to k1 over p. This implies that k1 equals hp. Therefore k1 is equal to 10 times 6, which is 60, because h is 10 when p is 6. P is equal to k2 root t. This implies that k2 is equal to p over root t, and therefore k2 is equal to 6 over root 144, because when t is 144, p is 6, so we get 6 over 12, which is 1/2. So now that we know k1 and k2, we can figure out the rest. So 60 over h is the same as p, and root t over 2 is the same as p. So therefore 60 over h is equal to root t over 2, because they both equal p. This becomes 120 over h when we multiply both sides by 2, and that equals root t, and therefore h is equal to 120 over root t, which is our final answer. The functions f and g are such that fx equals 3x minus 1 and gx equals x squared plus 4. Find the inverse function of x. Let x equal 3y minus 1. X plus 1 equals 3y, therefore y equals x plus 1 over 3, and we have found our inverse function there. Given that fgx equals 2gfx, show that 15x squared minus 12x minus 1 equals 0. So fx equals 3x minus 1 and gx equals x squared plus 4. F of gx is going to be the same as f of x squared plus 4. We replace x with x squared plus 4 for f of x, and that gives us 3x squared plus 4 minus 1. We expand this and we end up with 3x squared plus 11. 2g fx is going to be the same as 2g of 3x minus 1. So using g and 3x minus 1, we get 3x minus 1 squared plus 4, but remember we have to multiply by 2 to make our equation. So we now have 2 times 9x squared minus 3x plus 1 plus 4, and then we expand all of this and we end up with 18x squared minus 12x plus 10. In the question, we're told that fgx is equal to 2gfx, so we make them equal to each other, and then we simplify, and we end up with 15x squared minus 12x minus 1 is equal to 0, which is our final answer. There are only R red counters and G green counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 3/7. The counter is put back in the bag. 2 more red counters and 3 more green counters are put in the bag. A counter is taken at random from the bag. The probability that the counter is green is 6/13. Find the number of red counters and the number of green counters that were in the bag originally. So we can express the probability of picking a green counter as g over r plus g is equal to 3/7, where g and r are the number of green and red counters respectively. In the second situation, we're given 3 more green counters and 2 more red counters, so we can express the probability of picking a green counter in the second situation as g plus 3 over r plus 2 plus g plus 3 is equal to 6/13, and this simplifies to g plus 3 over r plus g plus 5. We now need to find the values of g and r to get our answer. So g is equal to 3/7 r plus g by rearranging our first equation. This leaves us with 7/3 g is equal to r plus g, and therefore r is equal to 4/3 of g. Therefore, the ratio of red to green counters is going to be 4:3, because we multiply g by 4/3 to get to r, so therefore if we had 3 green counters, we'd have 4 red counters. Using our second equation, we can then multiply both sides by r plus g plus 5, and we get 6/13 r plus g plus 5 is equal to g plus 3. When we expand this, we get r plus g plus 5 is equal to 3/16 g plus 39 over 6. Then we get r is equal to 7 over 6g plus 9 over 6. Now that we have another equation for r, we can create a simultaneous equation where we replace r with 4/3 g. So we have 4/3 g instead of r. This is the same as 8/6 g, which is equal to 7/6 g plus 9 over 6, which is what we just found. We do this because we can then multiply everything by 6, and we end up with 8g is equal to 7g plus 9, which means that g is equal to 9. Using g is equal to 9, we can then substitute this into our equation for r, which is 4/3 times g, which gives us 4/3 times 9, which is 12. So therefore, there are 12 red counters and 9 green counters originally in the bag. And that is Edexcel GCSE Paper 1H from June 2019 done. If you want to see any more videos from November 2019 or June 2019, just hit the links here. And if you want any extra help with your maths tutoring, make sure to hit the link in the description, because I'll be offering online group maths tutoring from the 24th of June. So make sure to click the link below if you want to get involved. Make sure to hit those videos, and I will see you in the next one.